Okay, folks, here we are back again, and I'm going to do some impromptu examples of working with classes. There we go. To a nice little empty directory for us to work in. Now, normally I like to set up my window arrangement here so that I've got these guys side by side. And that's a good way to do it. Today I'm going to do something that's slightly different. Let me get us into the same directory. Okay. So what I want to do now is actually make two windows. There we go. Because this is going to help us illustrate using classes a little bit better. Okay. So, just like with any program, you're going to have to make your main, and, if you're wondering what these magic words I'm typing, Emacs is just a text-based or a console terminal-based editor that I like to use. I've been using it since the 90s, and it's just what I like. But you can use anything from Visual Studio to Notepad++ to whatever to edit your code. The actual tool doesn't matter. What matters is the code. Okay. So, our typical C++ program is going to look something like this. Almost always going to have your I/O stream included. Almost always going to be using namespace, standard, and you're going to have a main function that returns some sort of integer. Usually going to just be returning 0 because, why not? Though most people don't utilize this return in main as frequently as they should, you can actually tell whether or not your program completed successfully by actually setting different returns. So the convention is returning 0 is a functional state, returning values above 0 is you returned successfully but at particular different outcomes you might want to express to whatever program or users call or ran your program. And usually returning negative values is associated with some sort of error state, so something went wrong. But 99.9% of the time you just see people returning 0 in their main because that's simple. Anyway, so just making a regular old program that says hello folks. Okay, so let's compile our code. G++ main.cpp, and we'll call our executable main. Okay, and if we run our code, main, we get hello folks. Okay. So, let's talk about making classes. This has been exceptionally challenging for a lot of you, and that's okay, because it's sort of, until you get the hang of it, it feels a little counterintuitive. Once you get the hang of it, you're like, yeah, that's pretty much the only way this can work. Okay, so let's just talk about making classes. So what we can do is you can make structured sets of data and functions. So sometimes we want to have a data type that is just specifically for dealing with, say, calculating grades for a class or something along those lines. So if we want to make that in a way that we can reuse it, we make a class. And classes look like this. Let's just make a simple class to, say, we'll just call it example class. So what we're making here is called our class definition. Here you're going to have some typical, we'll say, typical parts of class anatomy. You're always going to have a public section, and you're almost always going to have a private section. It's not required to have a private section, but you at the very least have to have a public section. And what happens is variables you declare in public, the main function or whatever's calling your class can access those. It can read those variables directly. It can execute those functions directly. But if you put them in private, it can't read them. So for instance, let's say we make an integer called v and set it equal to 123. We'll call it pub v for public. Let's make another one called priv v for private and set it to 321. Okay. So let's compile our code. Remember, code compile, code compile. Do a little bit of coding, compile it, and then see what happens. Hey, nothing broke. That's great. Run it. It still runs just like we made it. So now what we can do, let's give us a little more room here. There we go. Okay. So one of the things that we can do is, now that we've made this, we can treat example class like a data type. We can make multiple instances of it. Example class class A. We can make another one, example class B. And what we can do now is we can print class A dot pub v. Let's get rid of that line. So we're just going to print what's in class A. Okay. Now let's compile our code and run it. And look, it pulled that value from class A. Now let's try to access priv v in class A. Oh no, it broke. That's because we declared this variable in the private section. And what that means is that only things that are written inside of your class can access that variable. Things outside of it, like your main function, can't access priv v. And perhaps more importantly, not just read, but you also can't write to it. You can't edit it. So if we do class A dot pub v, we can change that value to something like 456. And let's fix our code here so we can look at that value. Let's clear our screen, compile our code, and run it again. And look, we were able to change the value stored in pub v. Easy peasy, right? But if we try to change the value in priv v, the private variable, look, we get a compiler error. It says you can't do that. It's private. You can only edit it within the function or within the class. And show you an example of that. Let's make a function in here called void edit priv v. And this is what we call a function prototype. Some of you guys, I've noticed a lot of you when you're working with your code, just go right into it, man. You don't hold up. You I'm going to write my function right here and start doing stuff. Technically that's not disallowed, but it's not good programming practice. What you want to do is make the prototype, meaning essentially just the first line of your function inside of your class definition. And then outside of your function, say down here, you make that actual function. And what you do to make that is you type your return type, followed by the class name, example class, colon, colon, and then your function name. And now you can write your function. Now, we'll actually do an example and see why this is specifically a bad idea. So now, since this function is part of your class, it can actually access priv v. And it can change it to something like 987. And so let's just display some stuff. Cout priv v before. And we can cout priv v after. Okay. So we've written a good bit of code here, so let's just go ahead and compile. Oh no! Things broke! Okay. So there's several things to look at here. One of which is the error that we made for ourselves knowingly down here. We didn't undo it. So let's get rid of the code that we used as a bad example a few minutes ago. Let's save it and recompile. Okay, and look, oh my gosh, cout, it says it's not there. That's because you're going to need to have this guy, you're using namespace std, got to have that positioned above where you use cout. Otherwise, you're going to have to do std : cout for it to happen. And same issue here with indel. See, now no big deal. It all compiled. Okay. So now let's go over here and actually run our code. We can call class A dot edit priv v. And that's going to change the value stored in priv v to 987. So let's compile our code and run it and see what we get. Hey, look at that. So first, priv v before our edit. Now in our class definition, we initialized priv v to 321. So when we did priv v before, we get 321. We edit it, and we get priv v after is 987. So what I hope this is illustrating to you is that we couldn't change the value in priv v from the main function, but we can inside of edit priv v because it's part of the example class. Okay. Now this is starting to get a little bit hairy. There's a lot of stuff going on here. So usually what you want to do is actually make another file. And this could be called example class.h. .h is typically a header file. And here's what you want to put in there. You want to put in your class definition, this part right here. Okay, so we can copy that. We can paste it into our .h file. Now we can remove the class definition from our main. But let's run our code, or try to compile our code and see what happens. Oh no! Things broke! Ah! It says our class isn't there anymore. Well, it's right. We just removed it. If you remove something from your main and put it in a .h, you have to then include your .h as a directive at the top. And notice we're putting this in quotes. So if you put the .h file in quotes, it's going to look in the current directory where your code is located for that file. If you put it in greater than less than brackets, it's going to look in the compiler include folder, or in the include. If you change the location, it should look for includes in that location. But the simplest answer is, if that didn't make sense to you, just put it in quotes and make sure that your class file and your main file, your example class header and your main CPP are in the same directory. So let's compile it, and what? Example, oh, I didn't save it. There we go. My bad. Hey, now it compiled. Kind of cool, right? So let's run our code, and look, it executed just like it did before. Okay. But we've still got all this extra class stuff that we declared here. Usually you can move that to another CPP file. Sometimes people call these HPPs. Honestly, I typically see them just referred to as just another CPP. Okay. And we can get this guy, get rid of this guy here. And now save that, save this, and compile our code. Oh no! It broke again! What? Undefined reference? Oh my goodness. Well, we had problems with our header when we moved it. And we just moved this to a new file. Maybe we need to do the same thing here. What? Now we got the C out problem again. Okay. So what you usually want to do is things that you're going to be like common includes that each of these guys are going to be using, or namespaces you're going to be using. Even though you've got them in your main, you're going to want to make sure they're also copied into your header files as well. And things like, IOStream and whatnot. Okay, so let's compile our code again. Hey, and it compiled. Awesome! Now we can run our main, and boom. We're getting the same functionality, except now our code's organized in a better way. And when I say in a better way, all of the things that go on in our main function are located in our main.cpp. The class definition with the variables and the function names that we're going to be using for our class are all in the header file. And the code associated with the class functions is in its own CPP file. So this is one way to go about this. I told you I wanted to show you why this is a good idea. There's a couple reasons why not writing your functions directly into your class definition is a good idea. One is it lets you do this. Separate out your header information from the actual code you're going to be running. That's one thing. The other reason is let's take this code, what we got right here, and let's do what some of you guys are doing and write it directly into our class definition. So we're going to take that and we're going to comment out all of this code we've already written, so it'll be ignored. Okay, let's run this now and see what happens. What? Oh no! Something horrible happened. So gave us a linking error for our function. Now, I was actually hoping to see a different error, but that's okay. Depending on the compiler you're using, depending on the compiler you're using, this might actually compile. In Visual Studio, this will typically compile, and it'll give you a different error. The error that it will give you is that priv_v is undeclared. But wait, here it is right here. The problem is that, yeah, you've declared it in the private section, but the private section has been written after this code has been written. So you end up with this effectively not being declared before it's being used by this function. And separating it out like this helps you avoid that, and also helps you avoid this error too, apparently in GCC or G++. So the best way to go about doing this is like this. Put your function prototypes and your variable definition declarations in your class header itself, your class definition, and then keep your functions separate. Okay, I think that pretty much covers it. I guess maybe the last thing that I want to show you here is how to do a constructor for your class. So a constructor is a special function that's just named exactly the same thing as your class. And so when you make your class, when you declare it, it's going to call this function. And again, you can technically write it in here, sort of bad practice. So pretend that you can't, just for the sake of yourself and everyone who's ever going to edit your code afterward. Just put the constructor prototype here, your function prototypes here, and then write those functions in a separate CPP file, or at least outside of your class definition. So if we wanted to write our constructor, we could just write it in a way very similar to this: example class, : example class. That seems a little redundant, but the way, the C++ compiler maps out which classes are associated with which functions is using this nomenclature. The class that it's associated with, : and then the function name. Since the constructor is technically a function in your class with the same name as the class, you've got to call it like this. And so we made a new instance of example class. Yay! Okay, so now let's make sure we've got everything saved, and we can compile our code and run it. And look, it printed this twice. Anybody remember why? Well, let's have a look and see. Let's open up our main.cpp, and look, we made an instance of it called class A and another instance of it called class B. So as soon as these instances of the class were made, it called the constructor function. Yeah. So if you need to initialize things inside of your class, your constructor function is where you're going to do that. Okay, I think that covers the basic examples we wanted to go over today. Practice with this, check out online tutorials. A lot of you have seen this already. You just need some reminders about how it works. And so hopefully this will help get you started there. Okay, folks, hope you're all doing well, staying happy, healthy, and safe, and I will see you later.